wild project I decided to do. I don't even know how to start with Elm. Oh, maybe we should make like a template of template. Or even get like a shell. Maybe we can just like kind of modify the Agda one. Agda template. Okay. I don't know how Elm works. Maybe we'll need to make Elm file. We probably want to make have shell. Okay, sounds about right. But maybe it can like create a template for me. That would be cool. Attribute Elm missing. That's quite a problem, yeah. Oh, this being maintained 17 months ago. What does this do? Oh, look at that. Elm test, Elm verify. Do that like Elm reactor thing. There used to be what the fuck is language? There used to be that thing called Elm reactor. I like. Oh yeah. Okay, cool. And there used to be like an Elm reactor thing. We just need a shell to copy it. We'll make sure it's the latest. Oh, it's archived. Now merged into Nix packages. Oh my god. Oh, that's great. How does it work? I don't know. Elm packages. You're telling me I need to use Elm packages. Something up to Nix. You make me a shell. I don't know how Elm works. Compile this Elm. Okay, let's do Nix packages. We'll figure it out. In your Elm project available Nix project. Okay, that seems pretty useful. How do I create Elm packages? Create Elm app. There we go. Let's add that to our shell. I want to add all these things. We'll add Elm to Nix. We'll add all the Elm shit because I'm gonna forget. Elm to Nix. No, I want to install from GitHub. You want to have Elm create app. Okay. Maybe it also can create a library, potentially. Who knows? Which packages Elm package. Okay. Let's go into the shell with this. I also want to upgrade my pin too. That will be today. Which I turned around because the default year for standard writing date. Anyway, we'll upgrade to the latest Nix packages. And we'll enter the shell, which gives us what? Oh, this is the pin. Okay. And we'll enter the shell, which gives us the Elm to Nix thing, and it also gives us Elm create Elm app. And then we'll use kind of Elm to Nix. I don't know. We don't even want to have a Nix build. We just want to have an environment that I can maybe visit 2 years backup or something. I probably don't want to make a library. I'm gonna do it anyway. See if anyone cares about. I don't know. We'll see. Like maybe it doesn't even work yet. We probably also want to make some tests, right? It needs to, like, I should fix my camera, zoom in, but it needs to get dependencies. Okay, cool. Now we can do Elm, create Elm app. There you go. That's not what I wanted to build. It's not at all what I want. I wanted to do create Elm app. Did it do anything? Project directory. Okay, we can do that. Create Elm app dot. It's not, it's resisting me. Okay. We can do create Elm app, there. Or maybe we call it maps, I don't know. Maps. It doesn't work. It doesn't say anything for all tiles. Okay, that's something else. What project directory is the name of the directory with your future project. But it doesn't do anything. Like, I just told it to use dot. And it does nothing, right? Wait, did it do anything? Did I add it myself? Oh, oh, this is Agda, right. I forgot. Okay. I don't know, let's just look up the docs. How do they set up the Elm start new library? Maybe read that? Oh, it's complicated. Elm init. There we go. Maybe we should do that. Oh, I need to install Elm. Obvious. And Elm in. Alright, I need to. Hello, Elm projects always start with the elm.json file. I create them. Now you may be wondering, what will be in this file? How do I add Elm files to my project? How do I see it in the browser? How will my code grow? Do I need more directories? What about tests, etc.? No, I don't care about any of those things. Yes. Maybe I should follow that link. Generation work directory. Let's just start with a call. Mail and visual guide. Quick sample. Okay, let's just like dump this in. See if it works. I mean, it's doesn't help a lot, you know, if you don't even create the main. Maybe that's okay. So they run Elm reactor. That's the Elm reactor. Okay. Okay. I need the module name to be declared at the top of the view. You can do that. And you may be wondering, like, what does a guy that doesn't even know how to do this basic shit go around designing Elm libraries, you know? Well, it's like Haskell, so it's all super easy for me. I think that's the hubris I have right now. That's why I need to do this, to talk some sensibility to me, or succeed, you know? Oh, I probably should ignore it. Elm stuff. Think of it. Press alt, git ignore. I bet it also killed reactor. But you can make it a go again, you know. That's good job. Okay, I guess we have a template then. Let's actually commit this so that in the future, if I want to do like Elm template, I don't have to go to this shit again. Let's also add like that reactor thing to build. because I don't care enough, but that's all fine. Elm reactor. That's our build command, and that's our make file, to be honest. We don't want to have anything else. Now if you do make build, you'll end reactor. Okay, that all seems very reasonable to me. So, and I just add the make file so I don't have to remember the stupid way. There's shit. Add modify acta template into Elm. Okay, let's add a repository for that. Otherwise I'm gonna lose it. You know, at some point this computer will crash or file corruption. Who the hell knows? Still, I keep. No. Wait, is this Firefox? Oh, that's why it's so slow. Firefox. Open the... I guess this is stupid. Oh, actually, I'm looking at using the wrong browser. I don't close it. I'm not sure why it opened Elm, so I don't put Elm into small Excel. Okay. No, don't do any of those things. It can be public, that's fine. Don't anyone care about it. You know, if someone else wants to use it. We want to set the remote URL. Not that file path. Okay, need to fix that at some point as well. Origin. Okay, so we got an Elm template. We got the. Oh, we need to fix the README for. Okay. There we go. Cool. So now we want to clone this again into a separate repository. So I don't have to modify the template. So we'll clone Elm template into Elm. Well, what do we want? Generic key. Elm generic key. That seems so difficult. It is simply. Okay. How does it work though? How does the entire library thing work? Package Elm bidirectional data structure. Oh, it's already here. Why bother if it already exists, you know? A wrapper over dict in Elm core that allows you to use any type as keys. Unlike existing solution, it doesn't store functions in a data structure. That's probably what I wanted to do. It doesn't have any performance implication. Slightly higher memory usage. Requiredly to explicitly pass a function. The key type to a string. This library. Well, also shit make strings out of it. Type ID. String ID. I wouldn't use the existing one either. I would just make my own. Dictionary features. Set import any type without dictionary mapping keys to values. This dictionary can any non-function type key. Dict. The core libraries can only use variable key. Regular equality for parent key works anything but function. Those ones set to be predicate. Yeah, like my. I don't understand what they do. So my CTO said like, okay, it's not possible to use dictionary for like arbitrary types, and I was like, totally possible if you just posit a comparison function. But now I discovered the Elm packages, which have a bunch of implementations that already do this. And I thought this is such an obvious solution. Why don't the other people already do this, right? And then there's a bunch that just convert the keys into strings. But you guys, why not? What? I wrote a blog post about Elm. I made shaders in Elm. This is kind of fun. But we'll, how do you call it? We'll stretch Elm for a bit. Key value, similar to dict, but stores different types of values. Oh, and lookup of words? This one, or the one before? Elm dict. Oh, that's what it's doing. That's not even a dictionary. Really? Why would you put this into a library? What's wrong with you? That's amazing. Wait, so actually nobody has done this then? I mean, I don't think anyone has realized this shitty trick I have in my head. I'm just spitting out comparable. This is sort of the idea I have. A dictionary similar to dict without restrictions on comparable keys. You just have to provide a mapping to a comparable for either a tree. So, okay, look at this. What they are doing. This is sort of the idea I had. If you just provide a function for your key to the result, you can use that as hash or compare. But you know, this already exists, so why would I bother writing my own, right? Waste of time. Not quite any. Only if you can provide a function. Well, I guess we have an Elm template now. I'm not gonna do anything with it. I mean, we might as well implement it. Fun. Elm have vectors. Collection of types of fixed length. That's not quite what I meant. I meant array, I guess. Array. I mean, what you would want to do if you want to make it go fastly, rather than make it into any comparable, make it into an integer, and then just as backend, you just, you know. Oh. We can look at the source code of that any library, see what they're doing. We're gonna modify this a bit. Oh, it's already in the core library. The elements in the array must have the same type. Can we populate this part? Yeah, we can. Let's make a dict with array backend, and then make it work with any value as well. So we will have like the fastest dictionary, and it will work with any key as long as you can provide an integer. Let's just crush them. I just need to know how the how this works. So we'll, you know, put it into dict any, or it's not any, dict, I don't know. It's all just hashing. Does he already have it? Not quite right. It's a hash one though. You understand, hashing is not the thing I wanted to do, because if the user can just provide me an integer, he can go and make it go faster, because like the hashing operation also costs time. But then again, you know, if the user already would know the integer, why would he even use a dictionary? That's a good question. Maybe this is like the most sensible thing you would do. Really? You see that? Oh, it's key. Hashing quality. Type classes. Are you shitting me? This is beautiful. Fuck you. Okay. I think my point was made. Just by this module. This is fantastic. Equality in hashing. Just puts in an empty salt. My god. I think this is like the end of Elm. You know, we can implement monad. God. This type classes can be defined as a record in the instances provided explicit value. Elm has problems which type classes can solve. This package aims to do exactly that. I love this so much. Okay, we also I guess we have IO. Man, this is fantastic. Provides pure Elm tools aimed to make programming Elm more composable, even admitting the bullshit of the Elm architecture. The classic application of the Elm architecture structures like this. Boy, you could also not do that. Oh, just overrides the thing. Because it actually doesn't force you to use the Elm thing at top level. My god, the stuff they come up with, it's crazy. But the other thing there was like this guy and he made some profunctor bullshit to make Elm apps compose. But parse interesting. How many of these are there? It like displays everything on one page. I wonder what they wrote this in. I guess this idea is kind of off track because, you know, there already exists good alternatives, so it's a bit pointless to make my own. I can just, you know, point to those libraries instead. Be happy with that. Cool, we don't have to do any Elm anymore. What else did I want? Oh, we can fix my compile errors. That's fun. Always fun to fix compile errors. So I guess we're no longer to hell with Elm. Fix compile errors. Sorry guys, Elm is off tracks. We already know it exists and the solutions are pretty good. So why bother, right? Kind of boring as well, you know, copying existing stuff. We can make a red-black tree. That's actually a pretty good idea. That's actually a really good idea. Let's actually do that. And we won't use comparable, we'll have our own thing. Red-black tree are crazy fun to do in functional style. Oh, why did they move away from that then? Oh, actually. I guess we just, like, if you want to implement something for a programming language, you just never search for it. It's like 2 years old as well. Crazy. Well, no red-black trees either. Oh, it's like the one in closure, okay. Kind of array page. What is that? Is that the one with the massive mapped? Hash array mapped trie. That combines. Is this the one that has like 64 branches or something? It's like basically it's like a binary tree, except you have 64 choices at every node. A typical implementation of each node contains a table, fixed number of AND slots, nil or points to AND is commonly allocated to expensive nodes contain a bit and bit long. I was actually thinking of making a structure like this in Haskell and then making AND independently typed. But you know what? Probably someone has already done this. I just get depressed if I start searching shit. Or maybe dependently types. No, actually, it doesn't look like it. They don't do the thing I said. Well, they don't make the N configurable at all. They say, hey, rotation. That would actually be pretty fun to try and do that. I don't know. I'm not sure how difficult this is. Try. One of the harder end of data structure. Oh, this makes me want to look at the source code of it. Doesn't look. Yeah, it looks like a big ass module. Like, fuck. Why is there so much stuff? Yeah, I remember the one in Clojure because it goes so fast, right? That's like one of the big selling points of Clojure. Get these crazy fast. Okay. Well, actually, I don't really like so abstract. Well, if you make your own really fast hash trees with nearly ideal characteristics. These hash trees require no initial. They are faster and significantly less spaced. Chained or double hash trees. I don't know what chained or double hash trees are. RRB. I've never heard of those. I remember Rich Hickey talking about the 64 based hash tree, and I was just like, oh, could you and polymorphic? You could. Oh, thanks for the resubscribe. Wow, 14 months. Jesus. Why? You're like my only subscriber. Everyone else has left. Welcome back. RRB. Factor. But they're just vectors, right? Common interpretation is based on tree. Fixed number of children per node, which allows fast index lookup. What's the difference with the other one? Relaxed radix binary balanced vector allows vector. Okay. Well, we can make an attempt at the other one. Like, I don't know what this is. I don't know why you started talking about Lumi. Oh, okay. But I mean, humped map. Why is there an Elm tab? Oh, we actually originally started with we are no longer doing it because everything already exists in Elm. So I don't know what we're doing right now. Looking at maps. That's a better type. Looking at maps. Stupid button is below. Oh, maybe because why are you so hostile against Elm? Don't you know there are type classes in Elm? There are type classes. There is the IO monad as well. We have IO in Elm. What's your problem? It's almost like real Haskell. My man. We have monoids, semi-group. It's all there. We could also make like a monad if you want. You know, not a big deal. We can do that. Actually, let's do that. Let's just fork this guy's shit. And we'll make a PR. It's such a shitty thing to do. Everyone's gonna hate me. Whatever, go there. And then we'll go back. Type class. Oh. We'll start with functor. And we'll do like 0 documentation as well. A to B. F of A. Functor F. Can we do for all? So putting together a tuxedo laptop. Can decide 16 or 32 gig. Never had more than 16. Well, if you want to run multiple virtual machines, kind of nice to it. And the other thing is that, you know, if you have the money, like, it's not like developers are getting better at dealing with memory. They're getting worse at it, you know. Like, we have too many new developers, basically. And too many new developers and none of them are good. So, yeah. But I'm the one depending on it. Yep. No, man. Build. I just wanted to build. Why can't you build? React. Oh, it's opening Firefox here. Because it thinks Firefox is not. Shit. Stupid Elm. How do you make it build? Compile certain things. Yeah, like Haskell. What about your Haskell job, man? Gotta add functor. Maybe we don't get this. F of A. It doesn't have higher kinds. It doesn't? That's the problem. We can't do this. I remember now. This is why I got so annoyed by Elm. Oh, we learned something today. So Elm forbids us to make these valid. I already was confused because this guy was apparently hellbent on adding all type classes to Elm and just saying like, guys, we need this shit. Add all the type classes. Why didn't he do the more obvious one like functor? Well, this is why. Now, a wise man would quit here, but I am not. We need to fake higher kind. So AB. Instant read. Well, function arrow is higher, right? You get 2. Why doesn't the other thing get? Oh, pin 2. I want to get out around. Ah, I see. AB. So we add a pointless type kind, and then we can do this. Then we're happy. Happy now. You are happy. Okay, we solved that. Tons of examples how to work. None of them have higher cover. Yeah, I was just before giving up so quickly, like Skybro and going into a repage. I persisted a bit longer. Like, my patience is running dry quickly, but I don't think the guy is gonna accept my pull because it's dumb. Now, how is this slow to type check? Find F of A to F of B. This is kind of annoying, because then you have to wrap your thing into a kind first, and you're not really getting the argument. Just can you put a maybe in there? So let's implement this for maybe, right? Functor maybe. What? You can pass type class argument. I do use what? You're all higher kind hackers. That's how it's called. What? But how do we do it in Elm? Let's first see if this compiles. I don't know why I have to use my browser. This type alias as recursive, forming an infinite type. When I expand recursive type alias, it just keeps getting bigger and bigger. What? It is confusing me a lot. Normally I can give a fuck. I mean, fairly specific hints. But something is really tripping me. Oh. I don't know, man. Thanks for blocking Elm. Not quite Scala expensive, just a macro. Okay. I'm starting to give up. Fuck. What just happened? Or did I kill it or something? What? What's going on? It seems like it's getting worse and worse. What? Oh, this is... I think we found a compiler bug or something. Okay. Maybe it's this? Platform export not defined. What does that mean? Okay. What's the difference between a type and type alias? What is this stuff? I don't know, man. Just do something. Can't you just make a tuple or something? I hate Elm. I don't think we're gonna do this. We don't need that in Elm, you know. Why is it tuxedo laptop? Oh, it's probably like 2 years ago model. They tricked me like that. They gave me like an old model, and it was kind of shit. It was more than not old stuff, new stuff. Yeah, I hear Intel isn't doing great in general. This is pointless. I think we're gonna give up on this. We may look at the what do you call it? Something trie. Hash array mapped trie. A low-level data structure which can be used to import higher-level hash map size. Such a updates the percent about. Yeah, I just realized how big this. I got task like have two my own. No, I want to be dependent. Alter. What the hell is alter node do? Int maybe v in 32. Okay, it's a pattern match. Look at how big this is. If you're a leaf node, if you're a hash collision node, do this stuff. If you're a bitmap index node, you'll do this stuff. If you're an array node, you'll do this stuff. Jesus Christ. Really good. It beats literally every Intel output best power. Is Lumi the author? Really? Do you see the author? Evan Wu 1. It's because of Skybro. He probably made Elm. He made Elm like a blocked word because he was just frustrated. Skybro, you're a bad mod. You shouldn't mute Lumi. There we go. Thank you. We tried. I don't think it's a good idea to continue that path. Well, like unless you get a suggestion on how to hack higher kinds, maybe we should just search for that. Polymorphism. Not extensible, but wait, they don't have this even in Scala. Password language, OCaml, Scala, Haskell, PureScript, or one of the few other ones. However, use of Java, just a lot of words. Don't use bad words. I am blocked. Same author as type class. Oh, it is! Man, that guy's productive. How would you know? Oh, the one that cracked me up so much in Elm type classes. Really? No, it's someone else. Nikita Volkov, right? And this guy is Kevin. Oh, it's shared author. I see what you mean. Okay. We're looking at another one. But he's also in here. Shared author. Hash array price. That's I was looking at the other one. What is this? It is this people like making these hash table based on hash array mapped trie. A couple of days ago I released STM containers library and it's supposed to talk about the motivation binary, feature and performance. Problem structure captures the update dual rows perfectly well. Needs data structure, it's a table chunks. He's making like a parallelized map deal hash. So it's like kind of like a skip list except for a map. It'll be very efficient for implement apps. So it got adapted languages like Haskell in order to library. For some reason didn't get much community. For the current project proves that HAMT can perfect STM. Essentially all we need to change nodes of trie. But like the reason I'm interested in this particular structure was more of, okay, you get this n, right? This branching factor n. Actually multiple of n. But like what I'm trying to say is that you want to make that configurable. And what I'm also trying to say is that you can make it configurable in such a way that the compiler will configure it for you. So you get like lossless 32-bit one. You can, for example, easily compare it to a 33-bit one and see if it goes faster or slower for whatever problem. Actually, what you then want is not so much just the implementation of this in a configurable manner, but you also want a like benchmarking thing, which brings us to criterion in Haskell. Oh, powerful but simple. Measure software performance, executing, and but I think I'm not gonna do this. Seems really complicated too. Can I just like read how this works? You can note that all the algorithms follow a 2-bit architecture. Now, however, trivial method to adapt 4-bit. So it's probably better to just use 64 instead of 32. In represent strike an acceptable balance desire for faster empty arcs. Found popular available on modern blah blah blah. Wait, what? Tries finding corresponding bit in map today as you can use. Oh wow! So what you actually want to do is make this somehow use the proper instructions. I see what you mean by it could be optimized even more, because you want to have some inline assembly for this, or you want to make sure Haskell is actually doing that. stuff. Big thing is that you really, yeah. So if you would use this CT pop thing, it will probably be an instant operator going through all the bit. Wouldn't know though to do that. Map sub trie. Hashing is well known. Remains in the sizing table and larger root size. Moves the hash table size. What? I don't understand what this does. Maybe we should just implement this thing to get a better understanding. Search for a key. It took me a while to understand it at all. I'm probably not going to understand it right now because I'm quite tired. Well, but I'm quite interested in this structure and I think it will be useful. I've been interested for, like, I've known about it for a while. I just don't understand how it works. You know, I like the idea of this becoming a compiled time variable. Basically, you would just, you know, insert like a natural kind, figure everything else out, right? Because it's just the size of the bitmap. What are we doing, by the way? Oh, I'm actually not sure what we're doing. We're just looking at maps. We kind of got blown away by everything is already being implemented in Elm, requiring to date like generic keys. I thought like so this guy at work told me he was like kind of blown away that you could have arbitrary keys as polymorphic variable in Elm dict, but you know, apparently the community would also know that, and so I got kind of annoyed by Elm. And then we also didn't even get higher kind of type, so we got even more annoyed by Elm. And now I'm like thinking, okay, maybe we can implement this data structure in Haskell instead, because it's cool. It's a cool data structure. It's like red-black trees, except faster and without red and black. And it's not a tree; it's more like a. But it's I guess it's also yeah. Makes immutable hash almost as fast. Yeah. Yeah, maybe this is actually a pretty good idea to do. Annoyance. Annoying. Is it? So I at least like at work implemented data validation. We're probably gonna open source it later. There's this library. This is like either, except you can accumulate on the error. I made this thing. I couldn't find it. I have not really searched. But I don't think anyone has actually bothered doing this. They were more concerned about making shitty maps. But that's cool, even though you're just kind of copying Haskell libraries, copy on write arrays. I actually have a zero use case for this. Well, like the only thing I had in mind was that this 32 could be dependently typed. That made me happy. There's a use case for dependent types. Isn't that cool? Oh my god. I mean, the hash function for us would just, you know, probably be type class. That's what they would do apparently. Hashable. It already exists. Yeah, that HTML library. That was crazy, right? I love that. It went faster than actually I have to look that up again. That was so cool. Never gonna use it, but oh, Page is online again. Yeah, I guess he's updating. Where is it? HTML. That was crazy. Like he just decided that he wants to make a servant for HTML, and he did it. So yeah, you can just implement your document, which is a type family, and then, you should look at these examples. They're crazy. And he just like, oh yeah, you can use this library, but it's probably I just love this. You could write JavaScript at type level. It's great. We can write JavaScript everywhere. And it goes faster. Because there's nothing to do. It's just like rendering the string. It's already done. Type of HTML is a library for generating HTML in a highly performant modular type-safe manner. I have no idea how this works. But he mentioned somewhere like, oh, you can use this library, but you maybe don't want to... Oh, wow. Right. You don't, please don't use the signatures because they're not that useful. They don't look as nice. Yeah, it's pretty cool, right? So this entire thing, it gets computed to like a type, and then the only thing, and then, you know, the compiler will type check this thing, and it will just be gone after that. It will be gone, it will just be a string, because the type check is like computing the result type. That's why it's so fast, because it's just, you know, presenting a string. Usage is fine, yeah. I wouldn't use this, but it's cool. Crazy. Yeah, it's like Servant, right? I wonder if you could do like arbitrary row trees, like, you know, you can make one after XML, you can JSON. I wonder if that's also the solution to the encoder, just to the codec problem. Like make a type and then let it generate your codec. Usually compile time. But sure, like if you think about it, he is trading runtime for compile time. So, you know, even if that compiles for 10 minutes, if that HTML needs to be served 1,000 times, probably, you know, saves cycles. Saves lots of cycles potentially, and you can cache your compilation result. You know, we're doing it kind of badly in Haskell because we have no, what we should do is just every module should become like Nix package, and you know, if you don't touch it, it'll remain cached forever. but or every function even, maybe even. There's actually like this guy doing that. He's like wrapping every function in Haskell into nicks. Or was I that? No. I was thinking about it, and then I heard someone doing that. Yeah. The story of my life, man. I think of some crazy idea, and then someone else is already doing it. Yeah. So what you would just like make a like every definition would become a entry. Every top level definition would be a entry in the Nix store. So as long as you don't touch the top level entry, you would get caching. Like the less extreme way of thinking about it is that doing that per module, but you could basically do that for every top level definition and just get rid of the entire. But that's kind of what Unison is doing, but you don't really need to design a new language around that. You just need to be like very tedious and get rid of the current Haskell module system. But then, you know, you usually only have to compile things until they work and you never have to compile them again. But the current Haskell module system is not really suited to a way of thinking. Can easily give you 24-hour compile time. Yeah, well, with that library, did I close it? Type of HTML. Type is always going to be much slower than computing real code macro. It's actually, I don't think, because unless he has undecidability, it can take 24 hours. But I think this is, because it's a row tree, right? I would assume this is actually decidable and you get like the progressive argument. I don't think, I would doubt there will be any loops or whatever inside his type station. No, undecidable, fuck. So yeah, that's unfortunate. So yeah, then it can do anything it wants basically. It means the type system becomes Turing complete, and it's basically a programming language. Because instances are pattern matches for function. Undecidability pattern matching. Because you have ambiguous is fine actually. No, it's just undecidable and unfortunate. What I would do is like try to find the undecidable instance. Well, it could be that he just added it for development. I don't think it was, well, what are we doing? I was just reading a paper at this point in a very distracted manner. Assuming the hash function. The initial step required to add new key to the hash tree are in search. Oh, maybe we should have looked at the search. Compute a full 32-bit hash for the tree for the key. Take the most significant t bits and use them as index to root of the hash table. One of the three is countered. First, the entry is activating the multi. Second, the entry value either matches desired success or not. Third, the entry has a 32-bit map subhash subtrie pointer base that points to ordered list on and subhash. The next 5 bits of the hash as an integer bit map. Spending my days in coffee shop. All the coffee shops are closed in Netherlands. Cafes actually. In Netherlands, coffee shops are something. Netherlands coffee shop. Oh, you get drugs in the coffee shop, so you get weed there. Marijuana. In a cafe, you get coffee. I guess you can also get coffee in a coffee shop. It just smells strongly there. Probably don't want to. This bit is 0. The hash table entry is empty. You know this. This is common knowledge. Yes, I've been coffee shop several times. Of course, everyone has. It's actually like really cheap way of getting fucked up, because you buy for like €5 a gram of weed, and like maybe quarter gram will fuck you up completely. So that's like getting fucked up for like 1 or 2 euros. It's crazy. This process is repeating, taking bits for the search fails. Are you going in the third case now? That's why you are so 5-hat. No, not 5-hat. Next. We're just trying to make a hash map that goes fast. How do you decide these things? I think the way to approach this, I mean, doesn't it describe it? It's based on simple notation of hashing key and sorting and trie based on this hash value. The AMT is used to enter a required structure efficiently. The array map trie, versatile data structure, an attractive alternative algorithm, any application. Hash trees, near identical characteristics that avoid traditional problems. Like the size of the initial tree it has during high dynamic resizing requirements. PhD not worth, definitely. Definitely not. During a search, bits are progressive hash. First the trie and value. What is a trie? I don't understand search. So take the most significant t bits and use them as an integer to index the root hash table. One of 3 cases may be encountered. First, the entry has a 32-bit map subhash table and a subtrie pointer base that points to an ordered list of non-empty. But you're not saying what happens in this third case. I think you need to do way more work then, right? Second, the entry is key value pair and the key either matches the desired key, indicating success or not, or indicating failure. Okay, so we get, are we gonna do this? Well, you know, we can just abandon the project if I get tired of it. That's the way to approach it. We can work a little bit on it. PhD. Like the problem I had originally with the PhD, that it would take like years where I could see any result of it. And at the time I didn't want to live in the Netherlands either, so I just didn't do that. and I would like have Utrecht, 1, 2. Well, it was kind of fun there. I had some other things on mind, and I think I made a good, like, you know, what do I care about knowledge of humanity? Really, no enough. Just got to give up at some point, right? I want to modify this. Okay. Edit package file. Replace every template with ART. Copyright. I think copyright is fine, right? GitHub. Use change state. Run make hpack kabel files. Remove template kabel. Edit change log. There we go. Template describe version 1 release. Actually it's TBA. Fast AMT. Right, let's edit default.nix, replace blah with blah. Let's copyright and license. Edit bundle to point to your. That's fine as well. Select desired badges. You can keep the link to Haskell back. You can keep the link which keep the one as well. Maybe we won't keep the builds. No, we'll delete that. I'll keep the link to Discord. Oh, we'll need to have a good quote as well. Yeah, maybe. We are the music makers and dreamers of the excellent. That's a bit shitty. Better ones. Little nonsense now and then is real. That's a better one. Maybe we should also add Willy Wonka. Okay, I should delete it also from the quote list. Isn't that process a lot easier if I have quotes on hand? Otherwise we spend like 20 minutes thinking of quotes. Now I could just take one out of my bag. Oh, we also need to oh, fuck. Last one. Yeah, please. Empty. Good. Select desired badges. Point build project. Fuck. That's not. There we go. Configure remotes. Give short product description. 3. Here we will link to a hash array map trie. There we go. Truncate this checklist. Add new quote for sure. Truncate motivation for using this step. Cool. Set up AMT. Cool. Okay. We can build now. I was just thinking we can start implementing it based on what they're saying. So we have to pattern match on 3 things, right? Compute to fill first. So this is for search, lookup. But I think we need to start with search. Well, we can start with lookup. They start. It is dumb to start with lookup. There you go. Data tree eval the entry is empty and the key is not. Second the entry value. But it's just like a data structure, right? Data empty value is T. Or second the entry is a key value pair. Entry empty. Entry eval empty. Key val. The desired key indicating successor. Third, the entry has a 32-bit map as sub-trie pointer. 32-bit map sub-hash. What the fuck is a 32-bit map sub-hash table and sub-trie pointer? Oh, the sub-trie pointer is to ourselves. These are leaves. And then sub-trie 32-bit map. What is 32-bit? Is it word 4? You get 4. I guess that's word 32. Haskell word. This is our bitmap. But maybe we can find a bitmap in Haskell. Like a library, data bitmap. But this should be based around word, right? We can just, you know, use bitwise bullshit, figure this stuff out. Oh, this is actually the image. I mean like bit field. A bit field, not a bitmap. God damn it. God damn it, we'll just use. Yeah, it is, isn't it? Word 32. Let's just implement it like a paper. Subtrie would be bitmap 33. But this isn't this is intact. This is a single value. This is not a map. Data bits. I need to attach a value to it. So it wouldn't be enough to use word. So we need to have like an int map, I guess. Right? Or am I interpreting this wrong? Key value pair. Third, if the entry has a 32-bit map sub-hash table. So what I understand from that is that we have in the subtrie we have a map of this, essentially. But if I would use map, we lose because this is a binary one. That is not fast enough. I don't have constant lookup. But use factor. Why don't we use factor? What's wrong with that? We need to have a dependently typed factor. Known as factor. Is it still being used? Project is probably still up to date. Like vec provides an approach. But what about we using vec? Then we get what we want, right? How fast did you look up? So what's the difference between using an array or a bitmap? Because they're both like integer based lookup tables, right? Why would you use one or the other? What's your lookup? Indexing. How fast does it go? It doesn't say. How annoying. It's safe though. That's pretty cool. Sparse small array. small array. Parse looks also pretty good. Yeah, we can easily type the primitive package. Structure provides various primitive memory related operations for Haskell. Exactly what we need. Small array are boxed immutable arrays. I need them to be unboxed, preferably. Well, array unbox primitive. Oh, arrays of unboxed types. We can't have that. Parse small array has two members. I mean, there's another library. I was looking at the right one, but this is another one. I was looking at the other day. Well, maybe this was announced. Think of it. Haskell library for array, not my man. Doing the array part of the map. It's a complicated data structure, okay? Lumi warned me. It was difficult to understand. And we're just like kind of making notes now on how it works, while also, you know, we're just kind of trying to describe the structure. Haskell. Maybe we can like derive an implementation of a web page. This is a map. What do you mean it's mapped? Is this a map? What? Why are you raging so much? Don't you see like the lookup key value? But like, you know, isn't that a bitmap as well? Because you get like the X, Y coordinate and then the value is just a pixel. You know, it's just RGB color. And then you just do that for 500 like that, 500 map. You know, map X, Y, RGBA. This is any map. X coordinate, Y coordinate. So maybe this is 0 and then this is 0 and then this is like black and this is like 1, 0, white, so you can like color it in entirely with this structure. Pirate ever. Thank you. Try my best, okay? Break the law many times. Best Haskeller ever. Probably not. What? Look at this. Oh, this is more of like basically doing some search maybe into this paper, which is a data structure for fast maps. I don't even know from when this. So someone made like this paper. He said like, okay, we do it like this, then make it go faster. And actually turns out that not that commonly known. I heard about it before. Like it was like an offhand remark, like, oh, I did it like this, you know, like everyone knows about it. No, it's not known at all. So like to see which is faster. Yeah, that's like maybe one of the see which is faster. We were just looking at one small part, trying to not the insertion, which is problematic. You don't have anything up. I am proud of you. Good job. It's called Raku now, right? Tower was like really into Perl for a while. I don't know. I don't think we almost made like a real thing after we got into, but I abandoned that as well. This is probably also something I'm gonna abandon. I need to make it look nice. You can use parse A. I think this is constant time lookup. Index. This allows garbage collected to read and mark to a card table. Small array likes to means that less map slightly faster writes. As long as the card table would have single card size 100. No, you can ask questions, sure. This is why I stream, right? Like I like to have to comment. Are you looking up functions in order to write the algorithm? I'm just trying to understand what this library does and if we want to use here. Because I'm actually looking at the data structure first, then a function. I'm thinking like because okay, so this is the thing, right? They are describing how this thing works, but they're not actually telling you precisely. It's not precise at all. It's like some offhand remarks basically. So they're trying a 32-bit map like a PNG or a BMP, you know. It's actually the same thing, kind of. Subhash table and subpointed by pointer. So I'm just trying to figure out what data structure should this be. The 30 entry has a 32-bit map subhash table. Trie pointer. I think this is the entire thing. So this is our trie. Then we have these first two options, which is either a empty or key value, and then we have the third option, which is like another one of these. That's how I'm reading that. And then, but the important part is this 32-bit map. Subhash table. What should this be? Is it a map of word to technically a bitmap? So I'm thinking like, okay, maybe this is faster. Supplementary question. Well, I mean, also look at that paper and understand it. This should be the source. I should not trust third party. Maybe they provided some. It's actually strange in computer science. They don't open source their code that often. It's just they describe shit and that's it. You just have to be clever enough to. There are a ton of variants, so most implementations don't exist. So that's what I mean, right? Like if I start looking at the, you know, we had the original one, Haskell as well. But if I start looking at their implementation, I'm just kind of getting biased how they want it to be. I'm just thinking this is these people probably put way more effort into figuring out how all this works and what the best is than just some guy reading their paper. At least that's how I'm thinking. They don't give any sample code order. The entry has a 32 trie pointer, hash potential points toward that one theory articulation like how CPU. But they have empirical. They have an empirical comparison here. Here they are comparing. I don't know what the numbers are. but I saw some empiricals. Well, okay. Actually, statistically, this is kind of shitty. It's just giving you the averages, not the standard. You're giving a fact on. So in paper like this, they talk about programs in general terms, and it's up to favorite language to try it in. Or do they write a paper language? There is no like languages don't really matter that much actually. I mean, so this is just general computer science stuff. And use whatever your favorite program. However, regardless of your language, empirical things matter. I'm just like kind of annoyed at it. Maybe I'm just like there's a fat chance I miss. I'm not really putting routing out of date. That's but I mean they go faster. Have them. Yeah, I want to do keylog. Well, do you have a better like the data structures themselves? They don't change the time. If you wanna learn something about computer science and about data structures, excellent way of knowledge that just sticks with you forever. The hardware gets more intelligent about applying certain optimization bias to micro concepts. Okay, let's just use that array. But like it goes on, right? The entry has a 32-bit map, subhash table, and subtrie pointer, comma, base that points to an ordered list of the non-m subhash table. What is that last part? On the page below, you see t pop build entry at base. Cache. Well, more. Read it taking 5 minutes time and search fails. If you it required, these only compared once. As with the terminating node, this contributes significantly to avoided. Notice that as misses are detected rarely require. So what I understand from that you get 32-bit. This 32-bit. Get 2 to the power 32. This amount of value. Does it make sense? Maybe we want to have an int map. Or maybe this array, like it seems like a lot. Card size is 128. Integer key value. Use the lazy. But if we use int map, we can't. Why not just look at the picture above? Oh, that's a good point. Base root hash table. So we got it right then, right? Key map base sub hash table. Yeah. So this is what I got. I thought it was like that, but now I'm looking at this and I'm sure it's like that. Okay, cool. That points to the ordered list of the... Is an ordered... No. I'm like thinking, okay, do I need to use small array? But that doesn't fit with like 32-bit, right? Entry has a 32-bit map, subhash, root hash. So the first one would... Then I'm thinking, can we use small array? But that's way too small. That's 128 value. But we want to have a 32-bit map. It's that many values. So then we need to use int map instead. Then I can make it programmable because it's int map based. Mergeable integer. Wait, is this integer or int? Okay, we'll use int map. I don't know. I guess we'll use this. I understand it. We'll get the word 32. We can't configure int map to be smaller. Figure that out later. Map of. Okay, we figured that out. It only took like nothing work for size 30. But if it's saying it's 32-bit map, it doesn't mean the array is 32 in size, right? It means it's much bigger in size. Or am I misunderstanding that? Word 32, which is int. Which is an int map, right? I mean, if we were to use small array first, this goes up to 128, which is way too small. So what do you suggest to use then? Word 32, and how do you do lookup? With bits, but from which data structure do you do lookup? An array? What? Well, because the 32-bit hash would be the full hash thing. Okay, I see what you mean. I'm confusing this 32-bit map with a branching factor. Am I not? Is that it? Because that also happened to be okay. Okay, I see your point. So we don't need to put any like this parser. But then, okay, let's look at the fact library because we can still do this. I don't do this right now. I don't want to deal with that type stuff right now. Parser, this parser, small array. Okay, we get the hashable key maybe value. So we first calculate the hash word key hash, full 32-bit hash. We'll go to data key hash. So we get the hash out. Hashable and int, which is an alias for we just cast it. Actually, we don't really care, I think. Maybe we do care. Let's just make it a word 32 to keep the algorithms. We'll just use from integral. You don't need int. We can also look at message. Oh my god, I have so much shit. Better. Move you to... Well, to be honest, I'll just close this entire tab. Okay, you're an integer. So we'll do from int. It's kind of dumb. What do I do from int? I can do enum. There we go. Okay. Let's see if this compiles. I think we need to add a lot of libraries. Okay, package, if hashable. Probably misspelled it. Hashable. Make hpack. I'll make hpack. Exactly. Okay, make build to Oh, you don't know, but okay. Just expose nothing, okay? Just expose everything. We don't actually care about the accent. We just not. Yeah, it's fine. Great. So let's see. We have some branching factor. Some branching factor, which is 33. This will be the size of the small array. Of the smaller. Not related to the size of the bitmap of the hash. Because I got confused on that. Hopefully that comment will make me less, but I probably won't read it. Okay. Okay, so that built. Take the next 5 bits of hash and use an integer to next the bit. Hello Cryptical, how you doing, man? Welcome back. I think I'm punching above my weight, like big time. We are trying to implement statistics. That's cool. I'm good. I actually today I did pair programming all day. Kind of fun. It was like mandatory slacking off with a paper. It's like a it's like the basis of a basically closure. How they make like fast dictionaries. So like one of the reasons they can do closure in a pure language is because of this paper, kind of. At least that's how I understood it from Vicky. So I was like interested in this paper or this idea for a long time. And then we got kind of frustrated because of Elm, and we kind of wandered off into paper. And I'm having an idea, maybe adding my own suggestion, like the branching, making this configurable. I think that will be interesting. I don't know, just make this configurable. No. So take the next 5 bits as bit as empty, hitting failure, the 1 bit below it using pop, and use the result as an index. What? Just doing some statistics. You figure out things. I actually I'm starting to form a plan around this like distraction entering. We are going to implement this data structure if we can, and then we are gonna benchmark the shit out of it with criterion, and then we're gonna see if we can make it go faster than maybe some reading. That's actually an interesting idea, because I have never done any benchmarking. And then, you know, we'll make it go faster, because we are actually on 64-bit architecture, so we just make it 64. Everything is fine. Well, that's amazing. It's always great if you can do some work which energizes you. Energize. Oh, you're gonna stream, man. That would be great. I like how Corruptical is pressuring everyone into starting the stream. That's like a great initiative. You go at it, man. Maybe we'll discover some people that are great at streaming. I need more content. That's the attitude. Oh. Okay. Goal of the is to connect them and then to benchmark. I'm quite happy with the CT pop. I'll work on cool problem. I'm not sure if this is a cool problem. I like my Elm idea better. It sounded more interesting. But turns out it was already done 1,000 times. So, you know, I immediately lose all interest if I figure something is already done. This kind of is already done as well, but I have an interesting take on it, and I couldn't find an interesting take. So here we are. Oh, it's just like Elm dictionaries. They are comparable by default. But I would like, okay, you can make this work for any key, right? You know, give it a function that does a comparison. But yeah, many people had that same idea. So it's like done to death. And I'm actually happy I did the search, otherwise I just would be wasting my time right now. Instead, we're reading papers. Look at us being clever, right? Alright, the CT pop. Right, we need to figure out how to do it. Search for keys. Emulation of CT pop. Oh my god. This is an abomination. Yeah, well, we need it. We better add it. Probably can implement this in C, come to think of it. Use some unserved from IO to call it, and we can use the assembly instruction. Maybe that's the way to do it. Then we can go faster. Let's add a to-do flag for this. We'll just implement it in Haskell. To implement in C. Use the instruction. Use and say farm IO to make compiler happy. Readable code. It's these are bit masks, so it's a lot less shitty than you would like. It's not that awful, okay? It's like they're applying the bit mask on this and they're bit shifting the map. Okay, that's okay then. And then apparently they also feel the need to subtract that from that. Okay, they make it positive, then apply the bitmap and then subtract it from that. Assign it at the same time. Yeah, okay, it's pretty awful. Yeah, really awful. I can't even do this. I need to rebind. Maybe it's just better to. I think I'm gonna like it gets an integer and returns an integer. Today a ctpop instruction is available. Most modern computer architectures include blah blah blah. Like if I'm gonna re-implement this haskell, I probably fuck up somewhere, introduce a bug. Maybe the right solution is not do that and write a C function instead. Or better, copy this. Ctpop. We need to have ctpop. Pop. What does pop count? This pop count already has it. Return the number of set bits in the argument. This number is known as the population. I mean, that's what they want. Why are they so cryptic about it? Why is the Haskell documentation better than the fucking paper? Just outdated. Finding the arc for a symbol S requires finding corresponding bit in the bitmap and then counting the one bit below it in the map to compute the index from the ordered subtrie. ctpop. Count pop. Just outdated. Pop count. Okay. I believe this is the same thing. Well, we learned something today. And what is it? It calculates the, so it counts all the ones. Set bits in the argument. But it counts all the ones. Different from the 0 of the alphabet used. So it just counts the ones. Dear God, why is it so hard? We need an operation to count the ones. Please use ctpop. No. No, we need to make this instead. Need an extra word for it. Damn it. Okay. So we wanna do another bit mask at the first 5. And I think I will have to. Yeah. This is gonna be a bit painful. We keep on referencing, like, would you say it's a waste of time to even read this paper, or did you say it's outdated? But I think the data structure is still using it. I feel like even though this is outdated, it's still punching above my weight. Otherwise, people may notice how trivial. That's probably it. So they actually do that, right? They want to make their work seem more important. Repeating, taking 5 bits. Take the next 5 bits of the hash as an bitmap. So count the 1 bits below. Oh, it actually tells it's doing that here. And use the result as the. I guess like they kind of forgot about their fancy wording and stuff and the importance of ctpop once they had to think logic. Fine or some layouts. I think it seems fine for learning. Yeah, that's what I mean. Right? You need to start some already. It's high level. Let's stop for this. These are. I will just do it above it so much. And now it's like kind of an. You don't really doubt why any of this. It's quite literally copied out from. What is 128? 2 to the power of 8, 6, 7? Do we have a word 7? I doubt it. I was hoping for a word 7. What? But they do it. They're already doing it. Just to classify it's T. But that's C++. Not in Haskell yet. Like the thing that annoyed me about Elm is that all that stuff was already implemented in Elm itself. So it becomes another level of pointlessness. If it's not just like I would assume that somebody would have thought of this, right? But it's another level of pointlessness if you implement it like if I would implement this in C++ and this would already exist, I would be like, yeah, I'm not gonna do that. It already exists. This entire endeavor. Well, maybe it's more of a learning exercise anyway. And that idea of Elm, I had a pretty good idea how to do this. And for this, I need to read the paper. I have no idea how to do it. So it's more of a learning exercise for me. But actually, I'm gonna end it here. We'll pick this up another time. I need to make sure to link. Okay, to do. Put it in the to do. Okay, like just add a bunch of actually doc this call and add lots of docs. Question is how you make a fixed int arbitrary size Haskell. What? Fixed int of arbitrary. Why do we need to fix? Arbitrary. No. We wouldn't use the word. We wouldn't use the word. We use a net. Yeah, we use a net. We don't use an int. We use a net row. Branching factor doesn't need to be. Does the hash branching factor not related to hash size? So word 32 not related to branching factor, right? I got it right? These are independent. We can make this and it's fine. It's fine, right? Because hash something different than branching factor. They are connected to the branching factor. They are not. We just went over this. I was confusing the branching factor with the word size. Remember? And then you said, but you are confusing the branching factor with the word size. We even made a comment saying this. Because this is where we decided to use small array. We can no longer use small array for this. It's too big. It doesn't make sense to use small array. But we can solve that with a type family. So we're gonna make a type family. We're gonna make this dependently typed, okay? And then we're gonna swap out the small array for the proper fact thing with the type family. It's gonna be fine. We can figure all this stuff out. That's the cool thing, right? We swap out the data type because, oh, you want to have a branching factor of more than 128. Oh, we don't need to use small array anymore. We'll use better array, normal array. And how do we deal? Oh, we can actually. How do we deal with the functions then of small array or better array? Well, maybe we'll use the type class. You know, we'll make all the generated code swap out, and it will be magical. It will be amazing, okay? And everyone's gonna use it. They're all gonna say like, "Oh my god, this stupid learning project, indeed." Nobody's gonna use it. But yeah. That's my argument. We can do this. Like, okay, it's implemented in C++ in kind of the same way I'm doing it, right, with the template. But doing like computation with template is kind of difficult. I think it's possible, but yeah. So, but what we can do in Haskell is if we get the net, we can pattern match on a net, go bigger than that. So that's I hope something that would be cool. Like, yeah, and just to learn about the data structure, which seems pretty fundamental. Anyway. That's another day. Should we have it parametric in general? No, I don't want to goes. What do you mean? Wait, what? Parametric? You mean like don't use it at type level, but make it like a argumental construction? That's another idea. But that's not what I wanted to go for because I would like to explore the type level shit. I write code to support both. That's probably possible, yeah. I wonder if you could make the type level one be like that as well. Somehow. That's another thought to explore. But I think this is interesting to explore because the branching factor, maybe you want to have like a different branching factor problem. Like it may go faster. Branching factor 10, you only expand, maybe that's better. Oh well, we'll see later. I'm gonna end the stream now, I'm tired. Thanks all for watching. See you later. Bye. Bye.